We now discuss the solution of a problem from the section Differential Calculus, and the problem is related to the continuity and discontinuity of a given function at certain points given in the question. This question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is, let f be a function from the set of real numbers R into itself, defined as f of x is equal to, when x less than 0, it is f of x is bracket e power x. When 0 less than or equal to x less than 1, f of x is a e power x plus bracket x minus 1. When 1 less than or equal to x less than 2, f of x is b plus bracket sine pi x. And when x greater than or equal to 2, f of x is bracket e power minus x minus c, where a, b, c are real numbers and bracket t denotes the greatest integer less than or equal to t. Then, which of the following statements is true? So, we are given 4 options. Option A, there exists a, b, c belongs to R such that f is continuous on R. Option B, if f is discontinuous at exactly one point, then a plus b plus c is equal to 1. Option C, if f is discontinuous at exactly one point, then a plus b plus c not equal to 1. Option D, f is discontinuous at least 2 points for any values of a, b and c. So we are given a function from the set of real numbers into itself, defined like this, where a, b, c are real numbers and bracket t denotes the greatest integer less than or equal to t. Then we have to decide which one of the following 4 statements is true. That is our given function, and we check the continuity at x is equal to 0, at x is equal to 1, and at x is equal to 2. Agreed. Why only at 0, 1, 2? It is a piecewise function, and bracket functions are discontinuous at integers. That also you have to take into account. Otherwise, they are continuous functions. So that means continuity is to be checked at the integer points, namely x is equal to 0, 1, 2. Agreed. We take case 1, x is equal to 0, continuity at x is equal to 0. For that, we check limit extends to 0 minus, that is of f of x, that is the left hand derivative, left hand limit LHL is equal to limit extends to 0 minus, so extending to 0 minus means this part of the function, that is bracket e power x, and limit extends to 0 minus of bracket e power x is 0. Why? Because 0 is less than e power x less than 1 for all x belongs to minus infinity to 0. Note down, x belongs to minus infinity to 0, e power x takes values between 0 and 1. For that reason, bracket of e power x as extends to 0 minus, it will be 0. Agreed. Okay, because the greatest integer not exceeding e power x, so that is 0. Agreed. And right hand limit extends to 0 plus of f of x, For 0 plus, you have to take this branch. So extending to 0 plus. So it is a e power x plus bracket x minus 1. Agreed. And recall, bracket of x minus 1 is bracket x minus 1. Why? Because bracket of x plus n, where n is any integer, that will be equal to bracket x plus n, where x is any real number. So this is equal to limit x tends to 0 plus of a e to the power of x plus bracket x minus 1. You further recall, we have the standard results. Limit x tends to 0 plus of bracket x. So we have limit x tends to c minus of bracket x is c minus 1, and limit x tends to c plus of bracket x is c, where c is an integer. Agreed. So now it extends to 0 plus of bracket will be 0 only. So this is equal to, and limit extends to 0 plus of a e to the power of x is a e power 0 only, because e power x is continuous, there is no bracket for this. Therefore, you can simply take it as a e to the power of 0. So a, and limit extends to 0 plus of bracket x is 0 minus 1, a minus 1. Now, to be continuous, the left hand limit must be equal to the right hand limit, and it will be continuous when a minus 1 is equal to 0. So that means f is continuous at x is equal to 0 if and only if 0 is equal to a minus 1, that is a is equal to 1. So f is continuous at x is equal to 0 if and only if a is equal to 1. Now we continue. Now we check the continuity at 1. So limit x tends to 1 minus left hand limit. So extending to 1 minus means x is tending to 1 from left, means this branch you have to take a e to the power of x plus bracket x minus 1. Now this is limit x tends to 1 minus a e to the power of x. Bracket of x minus 1 is bracket x minus 1. So use this. We have already seen that one. So now take the limit. Limit x tends to 1 minus is a e to the power of 1 only. Because it's a continuous function, simply replace by 1. But whereas limit x tends to 1 minus of bracket will be 1 minus 1. 1 minus 1. Use this one. So that is 0 and this is minus 1 as it is. So you will get ae minus 1. The left hand limit. The right hand limit x tends to 1 plus of f of x. So 1 plus means this branch you have to consider, and this is b plus sine bracket sine pi x is equal to b minus 1. Why? Limit x tends to 1 plus of b is a scalar, is a constant, b as it is, and limit x tends to 1 plus of sine bracket sine pi x is minus 1. Why? Because sine pi x, when x varies in the interval, open interval 1 to 2, it takes values minus 1 to 0. Minus 1 less than sine pi x less than 0 for all x belongs to 1 to 2. And that is why the bracket of sine pi x will be minus 1. So, agreed. And now further f of 1. F of 1 means x is equal to 1. If x is equal to 1, sine of pi. Sine pi is 0, bracket sine pi, bracket 0 is 0, and it is b only. Now, note that limit x tends to 1 plus is b minus 1, and f of 1 is b, and b is not equal to b minus 1 for any b belongs to R. That means the right hand limit is not equal to the value of the function at x is equal to 1. Therefore, it is discontinuous. It is discontinuous for all values of b belongs to R. So, f is discontinuous at x is equal to 1 for all b belongs to R. So this is what we have, and let's look at our options. And our option A says there exists some values ABC belongs to R such that F is continuous on R. It is not so, because in this case F is not continuous. F is not at all continuous for any value of that. So remember, for any value of B, it is discontinuous for all B belongs to R. So statement A is false. Agreed. And in the case 1, we have seen F is continuous for A is equal to 1. So F is discontinuous at least 2 points. So 2 points for any values of A, B, C. So because of the case 1, option D is also not true. Therefore, options A and D are not true. So we have to now look for only between B and C. Agreed. We go to the case 3 where we discuss the continuity at x is equal to 2. So the left hand limit at x is equal to 2 is equal to limit extends to 2 minus. 2 minus means x tending to 2 minus means this branch. So b plus bracket sin pi x, and that is equal to, note that we have already seen this one, minus 1 less than sin pi x less than 0 for all x belongs to open interval 1 to 2, and this value bracket of this will be minus 1. So it is a constant. Limit of x tends to 2 minus of constant is constant minus 1. So this is b minus 1, and limit extends to 2 plus of f of x. So 2 plus means x greater than or equal to 2 means this one. So this branch you have to consider. So this will be, note that 0 less than e power minus x less than e power minus 2. Yes, 0 less than e power minus 2 less than 1 for all x belongs to 2 to infinity. 2 to infinity. So that means bracket of e power minus x will be 0. So 0 minus c. So for continuity, left hand limit is equal to right hand limit. So it will be continuous at x is equal to 2 if and only if b minus 1 is equal to minus c, and that is f is continuous at x is equal to if and only if b minus 1 is equal to minus c. That means b plus c is equal to 1. So these are the 3 cases we have seen, and let us summarize. Thus, if f is continuous at x is equal to 0, then a is equal to 1. If f is continuous at x is equal to 2, then b plus c is equal to 1. And case 2, f is discontinuous at x is equal to 1 for all b belongs to R. Summarizing all these things, we say f is discontinuous at exactly one point, namely x is equal to 1, when a is equal to 1 and b plus c is equal to 1. Why? When a is equal to 1, b plus c is equal to 1, then f is continuous at x is equal to 0 and x is equal to 2. So let's look at our options. So now look at the option C. If f is discontinuous at exactly one point, then a plus b plus c not equal to 1. F is discontinuous at exactly one point, namely x is equal to 1, when a is equal to 1 and b plus c is equal to 1. When a is equal to 1, b plus c is equal to 1, a plus b plus c is 2, which is not equal to 1. So therefore, our option C is true. So that is the detailed discussion of the solution of the problem, which is based on the concepts of continuity and discontinuity of a given function. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.